My name is Bob Langer. I'm an institute professor at MIT. My research is at the interface of chemical engineering and material science and biology and medicine. And we do things like creating new drug delivery systems, as well as new biomaterials and ways of making new tissues and organs, which we call tissue engineering. In addition, one of the things that I've been interested in doing is not just writing papers, but actually getting the work we've done out to the public. So we've been very involved in writing patents and starting companies. We've written something like over 1,100 patents and that are issued or pending, and licensed or sub-licensed our technology to over 300 companies, maybe started something like 31. Well, people tell me that this is the largest academic biomedical engineering lab in the world. We have something like about 150 people here that are of all kinds of disciplines, ranging from actually practicing clinicians to molecular biologists to chemical engineers, electrical engineers, material scientists, synthetic chemists, all kinds of different people. So it's very interdisciplinary. And I think we've been fortunate that we have funding from about 20 different grants, both government, foundations, companies. Our research is at the interface of material science and biology and chemical engineering and medicine. And it involves actually a number of different things. One big area is drug delivery, and that would actually include nanotechnology. But we're also very involved in creating new biomaterials. Also, in some cases, some of the work that we've done has led to new pharmaceuticals, new drugs, particularly angiogenesis inhibitors. Those are molecules that can stop blood vessels from growing in the body. Also new heparins. And another very big area of our work is tissue engineering. A lot of that started here, and that has to do with using materials to create new tissues and organs by combining them with cells in many cases. We've been working on pills that you can swallow that last for much longer times than normal. These are still in animal trials, but they will be in human trials soon, I believe. So right now, when somebody takes a pill, it doesn't last more than a day. But one of the biggest problems that people in the United States face, and actually people face this in the third world even more, is patient compliance. People just forget to take their pills or their shots, and that just leads to terrible problems. Hundreds of thousands, if not millions, of deaths a year. And we've been working to solve that problem by coming up with pills. This is funded by the Gates Foundation, that can last for really any length of time, a week, a month, a year even, depending on the indication. Another advance we're looking at is trying to see if we can even deliver large molecules orally. Some other areas that start in the lab are advancing even further, or we've created microchips that you can implant in the body, and by even a signal, you can turn on a remote control signal and actually make the drug come out when you want to. And we're hoping someday to even put sensors on these chips. Another area that we've been working on is nanotechnology. We did some of the earliest work on polymeric nanoparticles, and we've also done a lot on liposomal nanoparticles. And these we're working on ways of targeting to specific cell types, which are in clinical trials, and also delivering molecules like siRNA that can turn off genes, or mRNA that could give you gain of function. So there are all types of really advances that are going on at different stages of development.